Well, despite some setbacks and some disorganization, vaccine distribution is going pretty well, all things considered, both on a local level as well as on a global level. What we're now starting to run into a problem with is vaccine hesitancy. Of course, people are a little bit anxious about this vaccine because they don't necessarily know all there is to know about it, and there are some side effects, and there have been some reports of some fairly dangerous, if not deadly, side effects. But the risk of those side effects is still significantly lower than the risk of the disease itself, and really the risk of falling down the stairs is about as severe as getting the vaccine. So in order to hopefully help with the vaccine hesitancy, I'd like to provide a COVID primer about how COVID works, how biology works, and how this vaccine works, so that maybe I can help people be a little less anxious about it and maybe be encouraged to get the vaccine themselves. So before we get into the actual vaccine itself, we need a quick primer on biology. Your body is made up of billions and billions of cells. Each cell has its own specialized purpose, from skin cells to liver cells to brain cells to blood cells to any number of different things. Each cell is alive and it contains the same DNA. That DNA is basically the blueprint on how to make you. It's how to make all of the different cells. And by turning on or off different parts of that DNA, it's able to make all those different types of cells. The DNA that's in your cells lives in the nucleus, the very center of the cell. And it's relatively protected against basically everything else. The cell works very hard to maintain the integrity of that DNA because any sort of errors could cause replication errors, which could cause something like cancer, for example. And there are many different ways that this can happen. It could just be a replication error when your cell is dividing. It might make a mistake when transcribing the DNA, or there are some viruses that do enter the cell DNA and modify it in such a way as to make it be altered, and this can also cause some forms of cancer. How viruses work is basically by hijacking your cells in order to make them do things that they shouldn't really be doing. So how the COVID virus, for example, works is it'll get into your cell, and then it will hijack that cell in order to make more copies of itself. And what a virus basically is just a bundle of various genetic material. In the case of COVID, it's an RNA virus, so it's basically half of a DNA strand, cut in half lengthwise, and the rest of the virus is basically proteins that allows it to be able to get into cells. Now, what makes COVID particularly infectious is this thing called a spike protein. And so the virus itself is covered on the surface with all these little spikes, these little proteins that look like pointy bits. And so this spike protein is able to latch onto your cell, stab it, and then inject the cell with genetic material, which will then cause the cell to do the thing that it's not supposed to be doing, i.e. infecting you. And the more of these viruses that you have floating around in your bloodstream and in your body in general, the more infected you're going to get, which is why the exposure of COVID needs to be of a certain amount before you get a full-blown infection. Your immune system, of course, is around. It's able to deal with a lot of viruses. So if you get infected with a virus of some sort, whether it be the flu virus or COVID or cold or anything like that, the immune system has a certain amount of innate immune response, where it will notice that this thing shouldn't be here. This virus just should not be in the body here, and so it will go ahead and attack the virus and get rid of it. If you're just infected with a couple of viruses, like a couple of COVIDs, the immune system, the innate immune system response should be able to take care of it, mostly. And so this is why people who get just a tiny little amount, a tiny dose of the virus, will get a very mild infection or possibly no infection at all, and thus they're not going to be contagious, they're not going to spread it to other people. If, however, you get a significant dose of the vaccine, your innate immune response can't really deal with that all that well, and so the virus is able to spread without the immune system being able to take care of it. Now, of course, your immune system does adapt eventually. You're able to produce antibodies, specialized tools to be able to fight the virus, but that takes time. And in that amount of time, that virus can be wreaking havoc on all your various different systems. There's lots of involvement in the vascular system, so your blood vessels and your circulatory system are being affected by this virus. Obviously, it's a respiratory virus, so your pulmonary system is also going to be affected. So You want to have that immune response take care of the virus as quickly as possible before it's able to do damage to the rest of your system. Most people, it's able to take care of it eventually, but for some people, not nearly soon enough. Some people are permanently injured, some people just suffer acute effects, some people die from this thing. And so we want to avoid that as much as possible. This is what vaccines are good for. Vaccines are able to get your body used to a virus without actually having to experience the virus itself. So basically, it takes some aspect of the virus that's able to suggest to your body, hey, look out for this guy. Watch out for something that looks like this, because that's a dangerous virus, and you don't want to get this virus. And then the body is like, oh, okay, I see. It's basically like a wanted poster. It sees the wanted poster, and then it recognizes what that virus looks like, what it behaves like, and then it's able to start producing proactively these tools in order to fight the virus. And so with these tools now floating around in your immune system, in your body in general, if the virus does happen to show up, the body's like, I've seen the wanted poster, I know what this guy looks like, I'm going to mobilize those tools, and I'm just going to go ahead and destroy the virus. And this causes a much better immune response than just the innate immune response itself. If you're just facing it with the innate immune response, it has to do all that learning process. But if you've been immunized, if you've seen the virus before, or at least know what the virus looks like, your immune system is way better able to deal with that. Now, we've been using vaccines for hundreds, if not thousands of years. We didn't know that what we were doing is a vaccine. We didn't really develop that technology until the last couple of hundred years. But way back in like 1000 CE, the Chinese were using pulverized smallpox scabs in order to inoculate people against that virus. By showing the body these scabs, which contain some dead virus of the smallpox virus, the body was able to recognize what the smallpox virus looked like and then produce the antibodies to be able to protect against the virus. So then when the actual smallpox virus showed up, and it would because smallpox was rampant, it would be prepared to be able to deal with it. And so possibly you wouldn't get quite as sick, you possibly wouldn't die from it. The first modern vaccine entered use when we recognized that milkmaids, people who milked cows as a living, they didn't get infected with smallpox for some reason. And the reason for that turned out being that there is a virus that's native to cows called cowpox. And it's very similar in terms of its structure, very similar in terms of how the immune system recognizes it. So by being infected with cowpox, which is relatively harmless, the immune system response of these milkmaids was able to recognize something that looks like cowpox, which also looks like smallpox. And so then with those tools, with recognition of that virus, it's able to protect itself against smallpox when it shows up. As we continue to refine these methods and formalize it and produce a vaccine that's even better than that cowpox inoculation, we've been able to basically eliminate smallpox. There is no smallpox anymore on Earth except in a couple of virology labs where they're kept under lock and key. So eliminated is smallpox that we don't even inoculate for it anymore because we don't need to. It's not out in the wild because the vaccine worked. Hooray! Unfortunately, not all viruses are quite as susceptible to vaccines. We've struggled with vaccines for various different things over the years just because they don't respond in the same way in the body as something like smallpox would. And so there are other viruses that we haven't really been able to eliminate. The other problem being that viruses mutate. And so a virus that works against last year's influenza isn't necessarily going to work against this year's influenza because it's sufficiently different that the immune response that the body has had against last year's vaccine isn't quite as good against this one. The other aspect is that the immune response does eventually decay. Your body does remember it, but the antibodies that it's produced aren't quite as many anymore. And so over time, that immune response will get weaker and weaker until eventually you need a booster shot in order that your immune system is reminded of these things. COVID-19 is a member of a virus group called coronaviruses. And coronaviruses are fairly common. They're oftentimes caught in childhood, and they oftentimes look just like a common cold. They cause some respiratory symptoms, sometimes some brain fog, a fever maybe, that sort of thing. And so children, when they catch something that is a coronavirus, they may not really even notice that it's something like a coronavirus. They may just think that it is a cold, and eventually the immune system responds and takes care of it. The COVID virus, on the other hand, it's a little bit more severe. It's, first of all, way, way more infectious than your average coronavirus, and also it is much more deadly. It's not a simple and benign childhood disease. It's something that can kill people, and especially people that are particularly vulnerable to respiratory ailments or cardiovascular ailments. The other problem with coronaviruses is that they're particularly resistant against vaccines. We haven't had a lot of luck with creating coronavirus vaccines in the past, for a few reasons that I won't really go into. The important part, though, is that we now have technology that we didn't have before, which produce different kinds of vaccines. Vaccines that are effective against coronaviruses and, specifically now, against COVID-19. Fortunately, we happened to be just on the verge of a breakthrough when COVID-19 showed up, and now we have vaccines that can deal with COVID-19 and possibly other coronaviruses, and the same technology is likely to be able to produce a vaccine against HIV and various other viruses that we've been having troubles dealing with. So there's 4 main types of vaccines. The first is the type that I've already kind of talked about, which is a live virus or weakened virus vaccine, wherein you introduce a virus of some sort, whether it be the equivalent virus like cowpox, or it could be something like a weakened version of the virus like polio. So what they basically do is they take the polio virus, they inactivate it using special chemicals or whatever else, and then they inject you with that virus. The immune system says, hey, there's a polio virus. Polio virus can't really do anything because it's been inactivated, but the immune system is concerned nonetheless, and it goes after it, and it produces the immune response that gives you immunity. Great. But this doesn't really work against coronaviruses. So we've got these 3 other technologies that are now introduced, which are now being used in COVID vaccines. The 3 different types of vaccines being used against COVID-19 are 1, the mRNA vaccine, which is what the Moderna and the Pfizer-BioNTech vaccine use. The second being the viral vector vaccine, which the Johnson & Johnson and AstraZeneca vaccines are using. And the third being the protein subunit technique, which there's one under development by Novavax, and I think there's a few others, I'm not sure. So I'll deal with these each in sequence. First, the mRNA vaccine, which is my personal favorite of these different techniques. The mRNA vaccine is a relatively novel technique using, as the name may suggest, mRNA. What mRNA is a messenger RNA molecule. So your cells have little protein factories in them. Each one of them, except for red blood cells and a couple of other ones, each one is able to produce proteins based on a message that's being received. Usually what happens is that the nucleus of the cell, which contains your DNA and all that good stuff, produces an mRNA molecule and then sends that out into the cell itself, and then specialized equipment in the cell produces a protein based on the blueprint that it's received. Basically what this is like a machine shop or a factory or something like that. You hand it a blueprint and then it produces the product that you're after. So the clever thing about the mRNA vaccine is that they've basically devised an mRNA molecule that produces the spike protein that's contained in the COVID-19 virus. So if, for example, this were the COVID-19 virus, and this is the little spike protein, basically the mRNA is the blueprints in order to make just this thing. The virus isn't even involved at all. You're not getting any COVID-19 viruses, you're not getting an inactivated virus or anything like that. All you're getting is a bunch of copies of the blueprints for that spike protein. And the cool thing about that is that once the body sees the spike protein, it's like, hey, this spike protein's not supposed to be here, and then it mounts an immune response against the spike protein. When something shows up that has that spike protein on it, say for example the COVID-19 virus, it already knows what it looks like. It knows what to do when it encounters that. And so then it uses the thing that's really dangerous about that virus in order to become a weakness of that virus. Now, this mRNA process happens all the time in your body. It's happening millions of times each second. Each one of your cells uses mRNA in order to produce the proteins that do everything for the cell. These are tools, these are messengers, these are just the various things that make the body operate are produced by using this mRNA to cause your cells to produce proteins. So when you get the shot of either the Moderna or the Pfizer vaccine, you're just getting a whole bunch of copies of this mRNA. It can't replicate, so there's only a finite number of these mRNA molecules. It doesn't enter the nucleus of your cell, so it can't modify your DNA. It can't do anything to modify your actual biology. All it can do is just enter your cells, go to that specialized equipment that produces proteins, hand it the blueprint, and then your cell goes, oh, okay, blueprint for a spike protein. All right, spits out a spike protein. And then the mRNA molecule is destroyed because by nature they are single-use objects. So basically, in each shot, you get a finite number of blueprints for the spike protein. Your cell creates, your various cells in your body create a finite number of those spike proteins. They float around in your body until your immune system notices it. Your immune system freaks out because, uh-oh, this thing's not supposed to be here, and then it produces an immune response that's able to destroy those spike proteins. And then when the virus comes along, your body's ready for it. It knows what those spike proteins look like, and it's able to just go ahead and knock it off. The second type of vaccine used by the Johnson & Johnson and AstraZeneca vaccine is called a viral vector vaccine. So this works kind of similarly. It uses the cells in order to produce spike proteins in order that your immune system is able to respond to the spike proteins and yada, yada, yada. But the difference is in how that spike protein is produced. What this basically does is it takes the instructions on how to produce spike proteins and it inserts it into a different kind of virus, but a weakened kind of virus, such as adenovirus, which is, I believe, what is being used in this particular vaccine. What this essentially does is it uses that virus as the vector in order to deliver the instructions on how to create that spike protein. So it pops into one of your cells, and then the cell goes, hey, okay, I'll produce these things. It makes some spike proteins, and the same process happens. So effectively, you end up with a bunch of spike proteins on your cells, and your immune system's like, hey, that's not supposed to be there, produces the immune response, and then you're ready for when the virus shows up. Similarly, this does not impact your DNA. It doesn't get anywhere near your cell nucleus. All it does is enter the cell itself and then accesses the cell protein production equipment. It also can't infect you with COVID-19 because there's no actual COVID-19 involved. All there is just the instructions for this spike protein, and the virus is detached from that. Similarly, the virus that's used as the vector can't infect you because it's been inactivated or weakened sufficiently that your body it's not challenged by it at all. Your immune system will just immediately jump on it and take care of it without any issue at all. The third type of vaccine being used for COVID just kind of cuts out the middleman of this. Instead of getting your body to produce the spike proteins, it just contains a bunch of spike proteins. They've just concentrated a whole bunch of copies of this little protein here. When they shoot it in your arm and your body's like, hey, a bunch of spike proteins, does the same sort of thing. So effectively, it's all the same idea, basically just introducing to your body copies of this spike protein, whether your body's making it itself or whether it's being introduced artificially just by shooting it in there. And as a result, your body is able to get used to the virus and therefore be able to defeat the thing. Now, of course, there's side effects. They've been well documented. There's, people get sore arms and whatnot. The reason why there are side effects is basically because your immune system is reacting to a threat. It notices that there is something wrong here, and at the site of the vaccine, there's a whole bunch of concentration of this spike protein, and so your body's going to do the normal things that it does to deal with viruses. So it'll cause some inflammation. So your cells will inflate. There will be increased circulation to the area, and basically it's it's going to freak out in the same way that it would if you've been infected with a virus. Now, of course, this isn't the virus actually causing damage to you. This is just your immune system responding as if it were responding to a virus. This, of course, though, isn't the only set of side effects that have been reported. The AstraZeneca vaccine, for example, has had some reports of blood clots, sometimes serious blood clots that have been life-threatening, and a handful of people have died. The reason for these blood clots isn't exactly clear as of yet. There is still research ongoing, but it's kind of hard to determine what this is because it is so rare. The current level of risk in Ontario, I believe I heard earlier, was 1 in 60,000 have actually experienced any set of blood clotting issue, and only very, very few have died. I think 2 or 3 people in Ontario have died, despite there being hundreds of thousands of vaccinations already taken place with this inoculation. The second shot of the AstraZeneca has much less of a risk of blood clots as well, for, again, unknown reasons. Currently in Ontario, the AstraZeneca first dose has been suspended in use because of an overabundance of caution. Until we figure out why it is that this happens and how to prevent it and what predisposes some people to the blood clots and not others, we're just taking a pause on that. Now, that doesn't mean that it doesn't work, and it also doesn't mean that it's inherently dangerous. It's just that we don't know enough and are being cautious in order to avoid more people being hurt by it. The other vaccines, on the other hand, very, very, very few people have had any impact whatsoever. The mRNA vaccine, for example, the reason why it's my favorite is that it uses your own body's natural immune response, and so it basically is inherently harmless. It can't actually do you any harm because it's just a bunch of mRNA copies. Some people as well are concerned about the long-term impacts of these vaccines, but there are none. There can't be any, because the mRNA and the viral vector that's being used are single-use only. They don't have a way of replicating. They don't have a way of continuing to operate in your body past that initial phase. The only thing that actually lasts in your body is that immune response. Your body continues to remember the identity of the spike protein, and it's able to continue to protect you against it. Beyond that, that's the only thing that actually lasts in your body. Within a couple of weeks, all of those mRNA copies, all the viral vectors are already gone, and you don't know any better. Of course, these assurances won't necessarily help everyone. They won't necessarily assuage everyone's concerns, and people are understandably still concerned that even though the risk is minimal, the AstraZeneca is only 1 in 60,000 of any serious side effects, people were still concerned that they may be the one that's going to get that side effect. But we need to keep in mind here the numbers. Humans are not great at understanding very large numbers. A number like 60,000 is just the same as a number like 10,000. It's just a really big number. We don't really have a way of conceptualizing 60,000 people. This city that I'm in right now has 400,000 people, and so if everyone were inoculated with the AstraZeneca vaccine, there'd be maybe 5 people in the entire city that was influenced by some serious side effects. So it's important to keep in mind that the risk of the side effect from the vaccine is significantly lower than that of being infected with COVID. There's a lot of people in the city right now, thousands, that are currently infected with COVID and more being infected all the time. If everyone were vaccinated, then the risk of being infected with COVID would be far, far lower, and very, very few people would experience any side effects whatsoever. So all in all, the balance of risk is on the side of being vaccinated, regardless of any risk. The chances of you specifically being impacted by any of these side effects is astronomically low, unfathomably low. And for the vast majority of people that do experience side effects, they're minor. They're just a little inconvenience, and that's why they keep you in the room for 15 minutes afterwards to monitor you. And there are medical professionals standing on hand so that they can deal with any problems that may arise. Now, the reason why it's important, though, for everyone to be vaccinated is that the vaccine isn't 100% effective. For the first dose of the vaccine, it's only approximately 60 to 80% effective. So if you're exposed to a large dose of the virus after you've been vaccinated with the first dose, there's still a decent chance that you might get infected. So obviously this isn't ideal, and that's why we need to continue to do physical distancing, continue to wear masks, continue to shut down any way that the virus may possibly infect more people, and also why we get a second dose for most of those vaccines. That second dose reminds your body and is able to stimulate an even stronger immune response thereafter, so that your body then is able to get up to 90-95% certainty. Now, we don't know what the long-term lasting impact of the vaccine is. We're not sure whether it's going to decay over time, and it probably will. So likely annual boosters for this will likely be necessary. And the other aspect is that the virus is continuously mutating. Each person that gets infected with the virus increases the chance of it mutating, because each person that gets it could replicate it differently, and if it mutates in a way that causes it to spread differently or causes it to not have the same shape of spike protein that the vaccine is instructing your body about, well, then we've got a different problem. So we need to, as much as possible, minimize the number of infections as much as possible, as well as getting people, as many people as possible, inoculated against it. This, in other words, is known as herd immunity. Herd immunity is basically having enough people that are immune enough that the virus doesn't have the ability to spread. Basically, the way this works is that if you have 90% of the people in a room inoculated against the virus and 90% immune, then if one person in the room has the virus, it's not got anybody else to really spread to, so it won't get to the various people, even though everyone in the room is only 90% inoculated. If, however, there's only a few people in the room that are inoculated and 90% immune, then, well, first of all, a lot of the people in the room are going to be infected, but then secondly, there's enough virus then in the room that the people that are even 90% immune are still possibly going to get it. We need to get upwards of 70 to 80, possibly more percent of the population to be inoculated in order to achieve herd immunity, so that the virus doesn't have fertile ground in which to spread. This is going to be difficult because of the vaccine hesitancy that I've been trying to address here. So I really, really hope that by explaining all this, it may assuage your concerns. If you do have any concerns or questions or clarification needed or anything like that, I want to know about it, because I want to be able to educate. I want to be able to help with this process. So leave a comment or anything else like that. And if you know anybody that has vaccine hesitancy, please do share this with them, and hopefully this can help assuage their concerns as well. Anyway, I make videos daily on a variety of different topics. Apparently today I'm a scientist. I'm not actually a scientist, but I know enough about science that I can educate about it. So if you enjoyed this content, like, share, subscribe, all those algorithmic things, and check out some of my other videos. A lot of it has to do with like social theory, philosophy, politics, that sort of thing. So thank you very much for watching. Thanks for your patience and your attention, and I'll see you tomorrow.